Okay, here we have a cylindrical cell with radius r equals 5 centimeter, height equals 40 centimeter, and the thickness of the shell is given as zero point 0.9 centimeter. So this basically represents the dr quantity. So first we will replace the volume of a cylinder, which is given by V equals pi r squared h. Here we know that h remains the constant, only the radius is changing. Only when the radius is changing, we know that we are getting a thickness of the shell. So let's differentiate this volume with respect to radius. And so we can write down this as a dV by dr. And this equals this pi and h are constant. So I can put them as in front without differentiating, and then we have to differentiate only r squared with respect to r, which gives 2r when we use the power rule. So let's simplify this. So this equals 2 pi h times r. This is dv by dr. Now let's multiply both sides with this quantity, that is dr, and when we do that we get dv, which represents the approximate volume of the shell, and this equals 2 pi h then r times dr. Now we will plug in the values of h, r as well as dr, so that we can determine the approximate volume of the shell. And so this becomes this is 2 times pi times h is 40 centimeter. I put only the numbers, that is 40. Radius is 5 centimeter. I write down 5. And then dr, which represents the thickness of the shell, which is given as zero point 0.9 centimeter. So I write down this as 0 0.9. And so when we multiply these quantities, we get 360 pi. This is in centimeter cube because this represents the volume. So the volume of the shell is found to be 360 pi centimeter cube, or otherwise, if we convert this to decimals, we get 1130.97 centimeter cube, and this is approximated to two decimal places. So, therefore, we say that the volume of the shell is either 360 pi centimeter cube or 1130.97 centimeter cube.